Lesson 28, we're going to simplify some rational expressions. In essence, all this means is that we're going to simplify expressions that deal with variables. So this is combining our exponent practice with factoring. Okay, so what we're going to be doing is taking something that could possibly be factored, factoring it, and then figuring out how we can simplify it from there. Okay. First of all, we need to identify what an excluded value would be. So let's do a simple example. If I have x plus 3 over x minus 4, my excluded value would be anything that makes the denominator 0. So the denominator cannot ever equal 0. It is not allowed. So all I do to find out what my excluded value is I take out whatever's on the bottom and I make sure that it cannot equal 0. So in order to do that, I set it equal to 0 and then decide which one is not allowed. So x minus 4 cannot equal 0, right? So I just solve it. Add 4 to both sides. I get x cannot equal 4. Sorry, my eraser was not coming out fast enough. Okay, so x cannot equal 4. So my excluded value is 4. And instead of saying excluded values are when x is equal to 4, we can just write x is not equal to 4, cannot equal 4. Okay, I will accept that. So moving from that, if I get something that looks like x plus 3 over z multiplied by x minus 5, okay, I would do anything that could make the denominator equal to 0. So the first thing that would make my denominator equal to 0 is if z was equal to 0. So z cannot equal 0. And then the second part would be anything that's inside of my parentheses that would make that equal to 0, because that's multiplication. There's a 0 product property there. So I would just take my x minus 5, set it equal to 0, and solve. So add 5 on both sides. So x cannot equal 5. So here are my two excluded values for this one. Any questions there? Somebody bent my camera. Sorry. Okay. Any questions there? All right. Let's get into the hard stuff, I guess. I just wanted to remind you of this one. Our quotient of powers, remember that if we have like x to the third divided by x squared, we just take the powers and subtract them, so it's 3 minus 2. So the answer to this one would be x to the 1 or just x. Okay, so the quotient power property just subtracts the bases. So when dividing things with like bases, we subtract their exponents. Okay, multiplying things with like bases, we add their exponents. Alright, so moving on from there, we have to remember that there's an excluded value here. X cannot equal 0. So start thinking of every time you see something with fraction, the bottom can never equal 0. So you always have to include an excluded value in your answer. So always go through there and say, this is excluded. Alright, so example 1. This should be on page 202. We need to identify excluded values first. So we're just going to get a few quick practices in on what excluded values are going to continue looking like from this point on. So we have 2m to the third over m squared. Our excluded values here would be what? M cannot equal what? 0. Okay, because m's on bottom. What can m not equal? It cannot equal 0. And then we have to simplify it. Notice that we have two bases that are the exact same in this problem. So in order to simplify it, I would move this one to the top and subtract. Remember, I always want to move the smallest one. So it would be m to m. That's it. So it's just 3 minus 2 is just 1. So we just write it. Don't ever put something to the first power. You just write down the variable. Okay, any questions there? So these are my two answers. 2m is my final answer for the equation. M cannot equal 0 is included in my exclusionary value. 2m squared over n squared, the base would be 2, and then n still. Yep. Yes, it would. Okay. You go from your original equation. Okay. On B, we have x to the 4th and x to the 7th. What is our excluded value? X cannot equal 0 again. These are really simple. Most of the time you'll just have a slew of things that cannot equal 0. And then we need to move which number? We need to move the 4 down, right? So I'm going to move the 4 down. What's left on top then? 1. Remember, this isn't just hocus pocus math magic here. We are moving these down. It's a divisionary product, okay? If we were using numbers, so a quick side note, if we were using numbers, this would be 3 to the 3rd over, say, 3 to the 4th. If I wanted to rewrite this, it would be 27 over 81, which would reduce down to 1/3. So what this basically does is allows us to move stuff without having to write this and then simplifying. It allows us to simply go from one to the next. Okay, it's just a quick rule that allows us to skip some steps, essentially. Okay, moving on to example 2. Is there any more questions on exclusionary values or simple quotient product? All right. So moving on from there, then 4x plus 8 over 8x plus 6. Now, if I was to ask you right now, 16, sorry. If I was to ask you right now, is there anything that I can simplify? I could divide by 2, right? I could simplify the top and the bottom by dividing by 2. Now, there's more to it, so the first thing that we notice is that, yes, we can divide by 2. The reason we know that is because all of the numbers are what? Even. Okay? That's what makes them so simple. Now, if I factored each of these out to make them in the smallest form possible first, we'll notice something else. So I'm going to factor each of them out. I know I can factor a 4 out of the top, so I'm going to go ahead and do that. I get x plus 2. And then on the bottom, I also factor out a number. What is it? 8. I can factor out 8. So I factor out 8, and I get x plus 2.
Question.
Yes?
Would it be the same if you like did it across and then the 8 would be 1 and the 4 and 16 would be 1 and 4 or 1 and 4?
I'm not sure what you're saying, Kaylee.
Like if you did the 8 and then 8 and then it just crossed
No.
1.
Remember, it's the whole thing. So this is an inclusionary symbol, so you have to think of it as if it were one whole thing rather than, it's like one term rather than 2. Yes. So we have an x plus 2 multiplied by a 4 and an 8 multiplied by an x plus 2. So since this whole thing is being multiplied, these two cancel each other out because it's the whole thing being multiplied because it's in parentheses. So now it's equal to 4 over 8, which is equal to what? 1/2. So factoring out the biggest thing first might help us out there. If it doesn't help us out, we can still simplify this. If this ended up being like x plus 3 and this 4 and 8 were still on the outside, we could still reduce it down to 1 and 2. We would just still have the things in parentheses there. Okay. So let's go back and look at our original. I need to see what this would be. What is our excluded value? Okay, we need to identify what our excluded value is. The bottom cannot equal 0. So I'm going to set it equal to 0. 8x plus 16 cannot equal to 0. So I subtract 16, and I get negative 16 equal to 8x. I divide by 8, and x cannot equal negative 2. So here's my excluded value, and here's my final answer. Okay? I have to start getting in the habit of always seeing what our excluded values could be. Questions there? Okay, example 2b. The problem is, write it down as I say it aloud, 3b squared minus 27 over b plus 3. So as a habit, so you don't forget, you might start out each problem with identifying your excluded values. Okay? So if b plus 3 is our excluded numbers, we cannot let them be equal to 0. So I just subtract 3, and b cannot equal negative 3. So there's my excluded values. b cannot equal negative 3. Now all I have to do is solve this a little bit. So I'm going to factor out as much as I can. Up top, what can I factor out of that? A 3. So I factor out a 3, I get b squared minus 9. Can I factor this anymore? Yes, I can. It's called the difference of two squares, right? So I can now set up two sets of parentheses. Because this is a perfect square and this is a perfect square, I can set them up as the difference of two squares. Okay, that's why we learned those really quick ones that were in the boxes. I don't remember what lesson it was. Anyways, that's called the difference of two squares. Anytime you see something squared, chances are we can factor it. Okay, and then we still have b plus 3 on bottom. So what does this allow us to do?
Cancel out.
Cancel some stuff out. So all we're left with as a final answer would be 3 open parenthesis b minus 3, right? Just like that. I would just leave it like that. We just did all that work to pull it all apart. Might as well leave it that way, right? Now, if it tells you to go ahead and distribute it out in the end, you go ahead and do that. But unless it otherwise specifically states, just leave it like that. Now, the reason I'd say identify your excluded values at the very beginning is because if you don't do that at the very beginning, chances are you'll get down to this and go, oh, I'm done. There's nothing on bottom. But there was something on bottom at the very beginning, so make sure we do that. Okay, moving on. On example 3. So simplify by factoring out a negative. So here we go. We got 6x minus 12 over 6 minus 3x. So first of all, I want to identify my excluded values. So I got to take the bottom piece, which is 6 minus 3x. We set it equal to 0. Start solving. So subtract 6. We get negative 3x equal to negative 6 divided by negative 3. So x then will equal 2, and it cannot equal 2. Okay, so that's our excluded value. Now we got to see if we can simplify this at all. So first of all, I don't like the way this is written because they're not both in standard form. I'm going to rewrite them in standard form really quickly. So it's 6x minus 12 still on top, but on bottom it's negative 3x plus 6. Okay, I just rewrote it so that I can get rid of the improper form. Now, on the top, what can I factor out of that one? I can factor out a 6. So I factor out my 6, I'm left with x minus 2 on top. On bottom, what do you want to factor out there? I want to factor out a negative 3. So x, now if I'm factoring out a negative 3 out of this one, it becomes a negative because I'm pulling out a negative, right? So that works out nicely. Saxon's fairly nice to us about allowing us to cancel some stuff out. So what am I left with? I'm left with 6 over negative 3, which leaves me a negative 2. Okay, and again, I have excluded values, but if I didn't do them right at the beginning, I may forget them. So don't forget, we need two things. The most common mistake I saw in tests last year is that the easy points, the excluded value points, were neglected. So I try to give you guys easy points, but if you don't take advantage of them, it works against your favor. Okay, example 4. I'm waiting. Okay. So this one's a bigger one. We're going to have to actually do some good factoring, so I highly encourage those of you who think working on the lesson is a great idea right now, you should probably definitely pay attention at least on this one. So I have a negative 2x squared minus 4x plus 30 over a 3x squared plus 21x plus 30. Okay, I've seen this a lot, so please avoid doing this. Because of these plus 30s, somebody wants to go, those cancel. Okay, you can't cancel, okay? Start storing this to memory bank. You cannot cancel things unless they are in multiplication. You have to factor before you cancel. Factor before you cancel. Okay? So what I want to do is I want to factor out this front one, and then I want to factor out this, this top one, and then I want to factor out this bottom one. So I'm going to factor them out separately and then put them back together and see what cancels. Okay? So I'm going to do this like I'm doing a separate problem. This negative up front, I never taught y'all guys how to factor things with negatives out front. So factor that out first. Factor out that negative. So I'm going to factor out a negative 1, and then I'm going to write the rest down just regular. So I have 2x squared plus 4x minus 30. Now I know how to factor this. Okay, so I'm going to set up my two sets of parentheses, and I'm not forgetting my negative 1 out front. Okay, so now I can start factoring this out. So I definitely have a 2x and an x. I know that for sure. Now I'm going to look at my back one. What does that tell me? Different signs. So I'm either going to have a plus or a minus and a minus and a plus. And then I have to start deciding what they're going to be. Again, I want to use the AC method, right? So my A is 2. We already have that one factored. It's 2 and 1. We don't have a choice. It's prime. And then C is 30. So I need to look at factors of 30. And I also need to look at factors of AC, which are 60. Okay? So factors of 60 that when subtracted give me 4. Factors of 60 that when subtracted, because it's different sign difference, give me 4. She says 10 and 6. I agree. We're so genius. So I'm going to write 10x and I'm going to write 6x right here. Because my middle is positive, my bigger one has to be positive. So my smaller one then would be negative. So now I'm just looking at these going, how am I going to get this done? Both of these are even, so I will look at factors of 30 that are half, because these are this 2 up here. So I'm going to look at 5 and I'm going to look at 3. So 5 and 6 and 3 and 10. Which one works is what we need to figure out. So which one, when multiplied by 2 and 1, will give me 10 and 6? 5 and 6. So I'm going to circle everything that works. Okay, so I'm going to use 5 and 6. 5 has to be in the back, right? And it has to be plus because it's going to be positive. And then that 4 leaves minus right there. And I have the 5, and now I need the 6. And then I just quickly check it. So 2 and 5 make 10. 6 and 1 make 6. And when they do them, they're good. Okay, so here we go. That is one of them factored. So I'm going to write it down. Equals -1, open parenthesis, 2x minus 6, close, new parenthesis, x plus 5. Sure, I just copied it. Okay, and then I have to do the bottom one. That one's a little easier at least. We don't have to factor out a negative right after that. So again, starting like a new problem, just copying that down. 3x squared plus 21x plus 30. Start with what you know. So I have 2 sets of parentheses. I always know I have 2 sets of parentheses. In the back it tells me I have what? Plus, so that means same sign sum. Because this is a plus, what does that tell me about my signs? They're both positive. So that's awesome. I factor out my 3 and I get 3 and 1, so I have 3x up front and just x. I factor out my c, which is 30 in this case, and I'm going to deal with that here in a second. And then I factor out my ac, and my ac is 90. So since it's same sign sum, I'm looking for factors of 90 that add up to 21. Factors of 90 that add up to 21. What'd you say? 6 and 15. I like it. So I'm going to have a 6x and a 15x. Now both of these are divisible by 3, so I'm going to consider factors that are 2 and 5 with the middle one. So here we go. That gives me 15 and that gives me 6. Which one of these work? 2 and, say that again? 2 and 15. Okay, so my 3 and 2 get multiplied. So 3 and 2. My 15 and 1 get multiplied by 15 and 1. So here we go, and here we go. And it works, right? So just copy it down. 3x plus 15 and x plus 2. Oh yeah. Did I write that right? Oh, I did. Got bad news for you guys. We kind of did that for nothing. It's good practice, but we kind of did that part for nothing. Did anybody else notice that these are all divisible by 3?
Yes.
Wish you would have spoken. Jeez. So it was all divisible by 3. That would have made our life a little bit easier. So let's quickly do this down. If we can factor something out of it at the beginning, we should do that. Okay? what we may notice here is that this is also divisible by 3. Do you see this? Everything inside of this one is divisible by 3, so I'm going to pull it out of there. So this is divisible by 3. I'm left with x plus 5. Okay, does everybody see that transition? Now what I should have done is pulled out that factor at the beginning. That would have made my life a little bit easier. Okay, so now all I have to do is rewrite the one up top. Okay, so at least we don't have to redo the whole thing. So I have an x plus 5 that cancels. So then I just rewrite the problem as what is left there. So I have a negative 1, a 2x minus 6 on top, and then I have a 3 and a x plus 2 on bottom. And I would leave it just like that. I wouldn't do anything more. Wouldn't do anything more. Okay, now here's the thing on y'all guys' excluded values, because I know y'all guys are going to forget some of this stuff. It's hard to find the excluded values here, right? It's hard to find excluded values here, but after we factor it, you can find the excluded values. It's when what's inside of here is equal to 0 and what's inside of here is equal to 0. So our excluded values are x cannot equal, that's plus 5, so it's negative 5. And x cannot equal negative 2. Don't need to work those out, or y'all guys good there? Good? Do I need to show you where I got those from? We are with that. Okay. That should be it for you.